Good evening, my 12th standard warriors. Welcome, my army. Time to study in this power-packed session, the photoelectric effect. It's an amazing phenomena, and you will see just for figuring out and explaining this effect, a Nobel Prize was won. It's a very, very fascinating topic. All of this with me in this one short session of the Pathfinder series with all of you. Hi Ramya, Anish, hello Veera, Rohit, Nirmala, welcome Shubham, nice to see all of you. So let's study photoelectric effect, the graphs, and also we are going to see the different equations, the work function, the threshold frequency, wavelength, effects of intensity, etc. and lovely problems. So are you guys with me? And if you are with me, go ahead, smash the like button and start answering the first question coming up on your screen. Hi Blessy, hi Anish, hello Akash, nice to see you back. Hello D Pratibha, hello, good evening Siddharth. The COVID graph is going down just like we have told you. A lot of students are asking, sir, you guys are wrong. You're comparing India with Africa. Africa is small, India is big. So India's graph will go big. No, it's the same. It's all about relative comparisons, and just like I told you a few days back, the graph has gone down. So I'm very happy about it. I'm very good, Abhishek. Thank you very much. Tomorrow I have exam related to rotation chapter. I'm supposed to revise this concept. I want a quick revision. Yes, Rohit, just watch my 0 to hero. Just search 0 to hero rotation. Just search it and watch it. Okay, it's a one shot lecture. Watch it. All right. Tushar Vishnu, that's a very interesting question. I will tell you about it maybe in a separate session. Definitely, Tushar. Will you finish dual nature? Study only. I finished dual nature in lecture 1. Today is lecture number 2. So it's already done. Photons and wave particle duality is already done. Nikhil, I wish I had Bitcoin, bacha. All right. So the correct answer is violet. Which photon is more energetic? See, the answer is simple. I'll tell you what. We'll talk about money and something else maybe in some other session one day. Definitely. I can see you guys are very interested in earning money. So definitely I'll help you out. So which photon is more energetic? I remember I had told you energy of any photon is basically hc divided by lambda. And for a violet, the wavelength is less, and for the red, the wavelength is more. So the one which has less wavelength will obviously have more energy, and hence the answer is violet. Very good, excelente. There we go. And based on this theory of photon, the effect of photoelectric effect was basically explained. Without the knowledge of photons and without the photon theory, you cannot explain the photoelectric effect. What is this photoelectric all about? You will get to know, but let me tell you one thing. The moment electrons see photons, they are going to jump out of the atoms, provided certain conditions are met. We are going to have a look at these conditions. Let's do a quick recap of the last session. So we have studied dual nature and the properties of photon. Photons are nothing but carriers of energy. They are packets of light, and you always know that the photons will travel at the speed of light, and no matter how you observe it, and photons possess momentum, mass is zero, and they also have fixed energy, and the meaning of the mass is not there when photons are traveling. Only the rest mass can be talked about. Remember that the rest mass is assumed to be zero. Okay, all right. And we have also seen that photons are electrically neutral. They do not get deflected by electric and magnetic fields. And the energy of a photon is hf or h nu, whichever symbol you want to use. H is the Planck's constant, f is the frequency, or nu is the frequency. H's value is 6.626 into 10 to the power minus 34. Momentum is h by lambda. Lambda is the wavelength. Very good. So this is a quick revision of what we did last lecture. Obviously, you can watch the detailed class. It's there in the playlist. Make sure you check it out. Yep. Photon will never come at rest. Definitely, Abhishek. No matter what you do, you can never see it at rest. Good evening, Nishu. Hello, Ash. Expected dates, March or April. All right. Okay. Sartha, you can definitely watch my same class over here. Whatever you're studying for JEE will obviously help you for NEET as well. Well, those of you who do not know me, my name is Shreyas and teaching kids for a long time now. I cracked JEE long time back. Probably you guys were just born or something. And yeah, I got almost full marks in physics and I always loved physics. And then I left my corporate sector job, entered into teaching, and the results which students gave in the JEE examinations, and so many hundreds of students cracked JEE examination, that motivated me to get into teaching full time. And here I am for a long time. And hopefully you too will conquer JEE in the years or months to come. So I hope you have smashed the like button, and have you hit the subscribe button? If you're not, make sure you do that. It means a lot, because that will give me the boost. That's my secret for energy. And just like you guys get energy through Complan or I don't know, Bonvita or milk or your chocolates, whatever. So my secret of energy is nothing but your love. That's it, nothing else. I'm not asking you for anything. Okay, and remember guys, if you want to ace in your JEE mains, if you want to ace in your boards, and if you're looking for some kind of a coaching, if you want some right mentor, if you want the right guide, and you want some kind of a definite plan, you want a test series, you want recorded classes, and maybe you're lazy enough not to travel anywhere, well, and if you're wondering, can we actually crack sitting at home? Well, the results out here speak for themselves. More than 1,500 students cracked JEE Advanced last year, and thousands of them cracked JEE Mains with amazing percentiles. So it is possible. You can study online, sit at home, don't have to travel anywhere, get the best teachers of the country, and you can see a lot of offers going on. And you can check out the description box. You can ping me on my Instagram, or you can just write a comment in case you have some doubts. Check out the link which is there. Avail the best courses for you, like the crash courses or the CBSE term course or the 11th standard course, whichever you guys feel you are comfortable with. Make sure you start your journey with Vedantu today itself. Don't wait for the JEE Mains dates to be announced. Let's talk about the photoelectric effect. Now, modern physics weightage is decent enough. I would say the entire modern physics with semiconductors and the communication systems, 4 to 5 questions. Now 4 to 5 questions is a big amount, considering there are only 30 questions max in JEE Mains. And even in JEE Advanced, there are at least 1 to 2 questions minimum per paper, 1 paper 2, so at least 4 questions. So assuming there are 18 to 20 questions in JEE Advanced, so for both the papers together, at least you can expect 3 to 5 questions, which is again a good number, even from JEE Advanced perspective. So definitely you cannot ignore this topic. Plus it's simple. So yes, it is easy, but you should understand, you should not make any silly mistakes. There are so many questions today where you guys will probably make a silly mistake. You will miss something. That's what I want you to understand. So let's revise. If you have studied this chapter already, you're watching this recorded, no problem. You're watching it live, no problem. But revise the entire theory. And yes, lots of problems coming up. Now, what is photoelectric effect? Simply put, light has energy. The carriers of energy, they are called photons. When these photons hit a surface, what is the surface made of? Atoms. Okay, so these are atoms. These are your light particles, basically photons. When light collides with the atoms, you might think, what will happen? Will the atom break into pieces? No, that's not what happens. The atom does not break into pieces, but there are some things inside that atom which are very susceptible to those photons. And the most susceptible are the electrons orbiting the nucleus. So the electrons are orbiting the nucleus. So when the photons fall on to the atoms, these electrons take that energy and they get very excited and they jump to higher energy levels. Now, if the atoms get excited, that's a good thing. Now, sometimes these atoms can get so excited that these electrons may jump out completely outside the atom. So if the energy of the light is enough to knock out that electron completely outside the atom, the electrons will be ejected out. Else, they will still be retained inside the atom. So if the energy is enough, the electrons get knocked out, and once these electrons get knocked out, you have a stream, you have a flow of electrons, as and when light is incident on that surface. So light falls, knocks out the electrons, enough energy, and the electrons keep flowing out. So you have a flow of electrons, which is also referred to as photocurrent. Why do I call it as photocurrent? Think about it. Photo, current, photons striking surface, electrons coming out, hence photocurrent. I hope that makes sense. So let's mark all of it right over here so that you understand. So these are nothing but your photons. These are your atoms, okay, which are getting knocked out, the electrons which are getting knocked out, atoms of the surface, and here you have the flow of electrons, which is also called as photocurrent. Photocurrent. All right, I hope this makes sense. Yep, you studied this in chemistry too. Yes, Aryan Singh, मी मराठी आहे, मला चांगलं मराठी येतं. हो. All right, so let's see if you know the fact based on the photoelectric effect. What is the time lag between the incidence of photons and the ejection of photoelectrons? Come on, think about it. Shreyas, motion in a plane is done long time back, long time back. Check the nurture playlist. Check motion in a plane. It will be probably one of the starting few lectures after motion in 1D. It's there in the nurture playlist, done long time back. Okay, so no lag. Lag, what do you think? Greater than, how much time delay do you think is there between a photon striking and an electron ejecting out? Kavi, you're little bit late. Good evening. Even if you're late, you can go back little bit, catch up at 2x speed even in a live class. That's the advantage of live classes on YouTube. But join in so that you do not miss. Catch up quickly. Okay, let's see. Jagdish saying B, Ramya saying C, Anish also saying C. Interesting. Students are confused. How much time does it take? What is the time lag between the incident photons and the ejection of the electrons? Let me tell you, it is very quick. It's very quick. So it is definitely not going to be 1 second. In fact, it is so quick that it is less than a nanosecond. 10 to the power minus 9 is a nanosecond. Nano is 10 to the power minus 9. So it's very quick. It's like, it counts and that's it. It's gone before you know it. Okay, so this is something which you should know. This can be asked in boards. This can be asked in mains. This could be asked in bit set, but not a JEE Advanced type of question, but something which you should be well aware of. Now, to study the photoelectric effect, in order to understand what does it depend on, what are the factors affecting the current, can I change the color of the light, can I change the intensity of light, so many questions to be answered, and trust me, it is not so easy. You might think, sir, intensity increases, current increases, sir, voltage increases, current increases, sir, frequency increases, current increases. No, it's not so easy. Alright, let's study this. So I make the setup and I divide it into two parts. You can say one is cathode, one is anode. So the light is going to fall, the photons are going to fall on the anode, and you will see the anode will eject out electrons, and the electrons which are ejected out, they will be catched by the cathode. That's how you can think and remember the name in case you get confused between anode and cathode. Cathode, catch. Anode, N electron. That's how you can remember. N stands for electron, or electron also has the letter N. So electrons are ejected from anode and cathode will catch these electrons. That's the basic setup. But when you do this setup, you want to make sure that there is no air inside this setup. What is the problem if air is there inside the setup? Then the electrons which are getting knocked out, they will hit the air molecules, they will ionize the gas, and so many crazy things will happen after that. Yep. Yes, Narayan Datta, it will be also helpful for the state boards, definitely. So this is how the basic setup looks like, and this is how it looks like when the light falls on it. This is highly exaggerated because you won't see the light coming like that. This is just depiction of the light, and you won't see the electrons because electrons are very small. So that's why I said it's highly exaggerated, but it gives you a sense of what is happening. You can see this is the photoelectric tube, which is completely free of air, it's completely a vacuum. Light is falling on the surface. This is going from that side to this side. All right. Now, this photoelectric setup is also connected to, it's also connected to a ammeter and maybe a supply, a battery, whose voltages can be changed. And this is very important part of the circuit, because we are going to measure what's the voltage difference between the plates. We are also going to measure how much current is flowing. We are also going to see what are the effects of these batteries. Keep this in mind. All right. So keeping all these things in mind, this is the basic block diagram of photoelectric effect, which you should know from board's perspective. From JEE perspective, most of the times this diagram is given and questions are asked based on this. So light falls over here, electrons are ejected, they are catched at the cathode, and you will see the current will start flowing. Why will the current start flowing? Think about it. The electrons, the moment they reach here, understand this part is depleted. There is complete lack of electrons over here. There is lack of electrons over here, because the electrons are going to be ejected out. The electrons get collected over here, and these electrons will flow via the circuit like this. So if the electrons go like this clockwise, remember the current will be anti-clockwise, because current conventionally is the flow of positive charges. I hope this is clear. Yes, Aryan, you can still watch this, bacha. There is not much of a problem that you will face, except for the fact that you should know energy of a photon is hf or hc by lambda. Hello Dakshin, good evening bacha. Now, once you have understood this particular setup, let's try to see what kind of variations we can do. It's blur. Is it blur? Just check this out. It should not be blur, bacha. It should not be blur. I can see that it is fine. Just check this out. Yep. Okay, it should be fine. Just check your resolution. Okay. Motion in a plane is there. It is called motion in 2D, Shreyas. Okay, just search for motion in 2D. That's the same as motion in a plane. Plane is 2D. Okay. Now, let's talk about something called as the threshold frequency. See, what is happening? Imagine there is some light which is falling on this surface, and we are saying electrons are ejected out. When this photon, okay, interacts with an atom, so this is my atom, okay, think of this then like my atom, this is my electron, this is my photon. If the photon lacks that energy to knock that electron out, then the electron will not even come out, and there will be no photocurrent, because the photon lacks that minimum energy to knock out that electron. I hope that makes sense. So, if the energy of the photon is not enough, if it is not enough like it is shown over here, then there will be no emission of photoelectrons. There is a minimum frequency below which photoelectric effect does not occur. That's what you should understand. So, I can say that there is a minimum frequency below which the photoelectric effect will not occur. Only after that frequency the photoelectric effect will occur. That frequency is called as the threshold frequency. It's that critical value of frequency below which photoelectric effect will not occur. So basically F, if it is less than F0 is that critical frequency, you will not get any kind of photoelectric effect. So I can also mention over here, for the photoelectric effect, okay, then your F should be more than or equal to at least F naught. At least have it as F naught. That's the minimum frequency. I hope that is clear. Okay. Now, if you guys have understood it till here, let's move ahead. Let's try to think what will happen for different colors of light. And by the way, before going to those different colors, let me show this to you if you do not believe me. So here I have a simulation of the photoelectric effect. I can choose different colors like you can see over here. Okay, I can choose different colors. This is the torch or light which falls on one side, one plate, and the electrons are collected on the other plate, and we can also measure the current and all those things. So let's see the current also versus the light frequency or whatever. Okay. Now observe this. Let's start the photoelectric effect and see what happens. So I can change the intensity. So I have started the light. You can see over here there is violet color light which is falling onto the plate, and you can see the electrons are getting ejected out and they are being collected over here, and you can see there is a small current which is flowing 0.043 amperes. Can you see that? Very good. Now out of violet and red, which color light has more energy? That was one of the first question, if you remember. Violet has shorter wavelength. Shorter wavelength means more energy, right? Do you remember that? hc by lambda. So if the light's color changes from violet to red, red has more wavelength, the energy will go down, the energy of the photons will be less. So maybe there might be no ejection of electrons. Let's try this out and see what happens. From violet, I'll change the color to blue. Okay, still I can see, oh, there is no current now. Maybe, look at this. There is no current now. These electrons were ejected long time back previously by the violet color. There is no ejection of electrons anymore. The photocurrent has dropped to 0. Interesting. So again, if I go over here, you can see only when I go to very high frequencies or short wavelength, I can see that the photoelectrons are ejected. It's crazy. Don't you see that? Akash, probably leave a comment after the video. I'll definitely help you out finding my micro courses. Crazy. So this is what you should understand. Now you might think, no sir, I feel that something is wrong. Let's do one thing. Let's make the color yellow or something. Okay, the moment I make it yellow or something, you can see the current disappears because it is less than the threshold frequency. Okay, what if I increase the intensity of light? If I increase the intensity of light also, there is no change. You might think, sir, intensity increases, more energy will be there. But there is a problem in that. Did you see what is the problem in that? Why doesn't photoelectric effect occur even when I increase the intensity of light? The reason is, when I increase the intensity, what happens? More number of light particles, photons will fall. Even if more particles fall, understand each photon can interact with only one atom. The energy of a photon is still the same. Just by increasing the number of particles, you have not done anything great. It's just that total energy is more, but each photon interacts only with one electron, one atom. That's why if each photon has or does not have that capability to knock out that electron, it won't be able to start the photoelectric effect. Yes, I hope this is clear. Intensity and frequency. Over here, intensity, I mean to say the number of photons. Okay, and frequency, frequency and the number of photons are completely independent of each other. Understand that, Jay? Okay, fair enough. Let's go back to our slides and see what should happen. 1 second, let me go over here. Okay, so what should happen if you change the color of the light? We just saw only above the threshold frequency the photoelectric effect will occur. But let's say the photoelectric effect is occurring. It is occurring. So let's say I go from red to green to violet. So violet has shortest wavelength, very high energy, and green little bit larger wavelength, little bit less energy. Red very less energy because the wavelength is very large, So hc by lambda. So maybe the photoelectric effect does not occur. Maybe, I'm just saying. Now, out of this blue and green or violet and green, do you think the energy of these electrons will be same? Think about it. Think about it. Do you think the energy of the electrons will be same? Think. Out of that violet and the green, violet has different photon, green has different photon, energy is different. Do you think the electron's energy will be different? And which one will have more energy? If so, think about it. Let me write it down over here. Out of green and violet, I can say the energy of the green light is less than the energy of the violet light. That means when the photons knock out the electron will also have more energy. So I can say the kinetic energy of the photoelectron by the violet light will be higher. That's what you should understand. So the kinetic energy will definitely depend on the color of the light. Very, very interesting fact. So the maximum kinetic energy depends on the color or the frequency of light. Yes, this is provided your frequency is more than f0. If it is not more than f0, then there will be no photoelectric effect. Like in this case, f is less than f0, so there is no photoelectric effect occurring. That's obvious. Okay. Thabu, no problem. You can watch the replay, bacha. Okay? Don't worry. Yes, no issues at all. Now, let's talk about the curve between the current versus the frequency. It's going to be very interesting. How will the current depend on the frequency of the light? What do you guys think? How will it be related? Let's try it out in our simulation first so that you get the feel of it. So I'm going to change the frequency and I'm going to see how the current will be affected. Observe this. So this is larger wavelength, this is smaller wavelength. Okay, this is larger wavelength, this is smaller wavelength. Okay, keep this in mind. Okay, now larger wavelength means smaller frequency. Smaller wavelength means larger frequency. So this is basically your small frequency, this is large frequency. Keep this in mind. Small frequency, large frequency, from red to violet. Fair enough. Now think what will happen when your light color is red or something. Okay, there is no photoelectric effect occurring. Okay, there is no photoelectric effect. I change the frequency, I increase the frequency, still no photoelectric effect. Now there is photoelectric effect occurring maybe somewhere after green color. Suddenly the photoelectric effect started because I have crossed the threshold frequency. I'm increasing the frequency. Photocurrent has increased. It has come up now. Photoelectric effect has started. I go to more higher frequencies. Oh, the current has increased. Interesting. I go to even more higher frequencies. The current has increased. I go to more higher frequencies. The current has increased. Now, unfortunately, this software is limited from infrared to ultraviolet. So I cannot go beyond that. But do you notice the graph of the energy of the electrons versus the frequency is almost like the straight line? So more energy, that means there are more electrons and the current is also more. So don't you see the current increases with the energy of the photons or with the energy of the light. So I have a feeling that this graph, right, this graph definitely should start only after f0. Below f0 there is no photoelectric effect occurring, and this is my current and this is my frequency. If I keep on increasing the frequency, the current also increases. Very interesting. That's obvious now. More the frequency, more energy, more electrons have lot of energy. So if they have lot of energy, more current will be flowing in the circuit. Now what will happen next? If I keep on increasing the frequency, if I had no limit, I go from ultraviolet to X-rays to gamma rays, do you think this graph will just keep on increasing? Think about it carefully. I have a feeling it won't, and I'll tell you why. There are limited number of atoms in that metallic surface. I don't know, it could be 1 million, it could be 1 trillion, it could be billion, I don't know. There are countable number of atoms inside that surface. Now think about it. If very high energy photons are falling onto it, very high energy photons are falling onto it, then there comes a time after which, even these high energy photons are unable to knock out any more electrons, because all the electrons which were knocked out have gone, because they had very high energy. So think about it, there comes a time where the energy is so high, so many electrons have ejected out, there are no more electrons to be ejected from that surface. So after a long time, you will see the graph will almost become saturated. This is like max, you cannot go beyond that. Yep, I hope this is clear. Yeah, it could be billions, it could be millions, but this happens after a very long time. For most practical purposes, you might not even reach there for standard colors, for standard metallic surfaces, because imagine knocking out all the electrons with that photon beam is little bit difficult, but not impossible. But that will happen after a very large frequency. I hope this is clear. Okay, great. Moving ahead. So yes, this is how the graph looks like. That's what I wanted to show you. Let's also talk about the work function. Since we have already decided and talked about the critical frequency or the threshold frequency below which no photoelectric effect occurs, that means there is minimum amount of energy which is required to knock out any electron. Minimum energy required to knock out that electron, that itself is called as the work function. That is called as a work function. And what's the formula for that? The formula for that, by the way, the symbol is phi, is HF naught. As simple as that. Your F naught is your threshold, okay, threshold frequency. So remember, photoelectric effect occurs only at or above F naught. So that HF naught will basically give you the energy, the minimum energy of that photon required to start the photoelectric effect. Hence, that is called as the work function. Usually work function is expressed in electron volt, so you can do that as well. You can also rewrite this formula as Hc by lambda naught, and if you're wondering what lambda naught is, this is also called as the threshold wavelength. This is called as the threshold wavelength. Fair enough. Now you can also write this formula as 1240 divided by lambda naught in electron volt if you want to. Okay, this is how it is important. Anish, is energy and frequency same? The relationship is same, Anish. More the frequency, more the energy. That's all. It's directly proportional to each other. That's it. I hope this is clear. Great, great. Okay. Now, somebody is asking, Narayana, what's the difference between photoelectric and thermionic emission? Thermionic is where the electrons get ejected because of thermal collisions. In photoelectric effect, the current or the emission of electrons is because of light. So because of light, when it happens, it is called photoelectric. Because of temperature, when it happens, it's called as thermionic. All right. Now, what do you think does this threshold frequency or this work function actually depend on? Don't you think this should depend on something? Yes, and it depends on the metallic surface. And I'll show that to you. Observe this. Okay, observe this. Let's change the wavelength of the light. Let's bring it down over here. And I can see that right now, yes, this dot comes over here. somewhere over here, the photo current becomes 0. Somewhere at 491 nanometers. Okay, 491 nanometers, the current becomes almost like 0. Somewhere like around 500. Now, if you change the metallic surface to something else, right now this was sodium, maybe I make it, I don't know, maybe platinum or something. Now that will have a completely different threshold wavelength, threshold frequency, work function. All these three things will be different. You can try this out. Okay, you can see that it does not. Oh, there it goes. It shoots up somewhere over here. Do you see that? Somewhere in the ultraviolet region. The threshold wavelength itself is different. You can see that graph. So, you know, the threshold frequency, wavelength, work function completely depend on the metallic surface, because reason being, the amount of energy required to knock out the electron will obviously depend on the material, the atom's holding power to that electron, how well it is bonded. So hence, it depends completely on the metallic surface. I hope this is clear. Yep, it's not density, it depends on the material. So each material, maybe gold will have different work function, aluminum will have different work function, like I showed you, platinum, sodium, all these things will have different work functions. I hope this is clear. Very good. Ankit, I have already answered it. You can expect around 5 questions totally from modern physics. Now, you should also realize that if something has more work function, then the amount of energy which is left out for the electron will be less. Think about it. So it's very important. Changing the metallic surface will change the work function, and hence the kinetic energy of the ejected electron will also be different. I'll give you a simple example. Imagine this. Okay, imagine the light which is falling has 100 units of energy. It has 100 units of energy. Let's say there is a material A and there is material B. Material A has a work function of, let's say, 20 units, and material B has a work function of, let's say, 30 units. Now, when light of 100 units will fall, 100 units of energy will fall on the surface A, what will happen? Out of that, 20 units is just used to remove that electron. 20 is the minimum energy to take out that electron. What is remaining is the kinetic energy of that electron. In this case, it will be 80, and in this case, it will be 70. I hope you see that. That means more the work function, lesser is the energy available to the electron. Less the work function, more is the energy available to the electron. Is that clear? Everybody understood this concept? Yep, yes, Bhaskar, I'll be doing atomic and nuclear physics as well. Separate class for atomic, separate class for nuclear, separate class for X-rays as well. Hello, Kumar. Hello, Jagdish. Welcome aboard. Great. Next question coming up on your screen now. Light of wavelength 3500 Armstrong is incident on two metals A and B. Which metal will yield more electrons if their work functions are 5 electron volt and 2 electron volt? Very interesting question. Let's solve this. Very good, Akash. Very good, Anish. Case of JEE Mains may happen in March. We do not know that. Let's prepare for March, but hope that it happens after the board examinations. Let's solve this question. If this is the wavelength of the light which is falling, let's think what should be the work function of that metal for which this wavelength becomes threshold. I'll repeat. What should be the, let's first find the work function of such a surface, all right, whose threshold is basically 3500 Armstrong. Basically, I'm trying to find what's the energy of this particular photon of 3500 wavelength. Let's find that out. It's not that difficult. So that phi will be h c by lambda, which I can also write it as 1240. But if it is in Armstrong, put 2 more zeros. So, or rather put 2 zeros after 124. So this will become 3500. This 0, this 0, this 0, this 0 went off, and 35 and 124. So 35 threes are 105, 35 fours are basically 140. So between 105 and 140. So that's basically around, roughly, I'm approximating it to be 3.5 electron volt, roughly, okay, give or take. I just need the rough values, I don't need the exact values. Now, this is basically the energy of that light. This is the energy of that photon of that particular light. Now think about it. This 3.5 is more than 2 but less than 5. This is very, very interesting to note. This 3.5 is less than 5 electron volt, but it is more than 2 electron volt. Meaning this energy of the photon will not be sufficient to knock out the electron from A. This 5 electron volt, that is A. It cannot knock it out. Why? Because the work function, the minimum energy itself is 5. The photon's energy is 3.5. How can you knock the 5 electron volt work function metals, atoms, electrons? You can't. This one is B. The work function is less than the energy of the photon. Definitely you can knock it out. So there will be no photoelectric occurring here. There will be photoelectric effect only occurring in B. That's very, very important. How HC is 1240? Basically, you just substitute the values. I'll tell you. I'll come to that. But did you guys understand why only B will have photoelectric effect? A will not even have it. So there is no point comparing when A does not even have photoelectric effect occurring. So basically, when you substitute H and C's value, H's value is 6.6 into 10 to the power minus 34. C's value is 3 into 10 to the power 8. This will give you in joules. Convert it into electron volt. So basically 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8. But you want it in electron volt. So divide it by 1.6 into 10 to the power minus 19. That will give you 12400. And you also need to take care of the powers in the denominator because lambda is in nanometers or in Armstrong. So you adjust the powers. That's how you get the value 124. Is that okay? All right. Okay. Very good. Moving on to the next question. Shyam Praveen, this is an English medium channel for all the English medium students. So that's why we'll be talking in English only. Sriji, I don't know whether I know you or not, but I'm pretty sure you know me because you are watching my lecture. Now moving on to the next question. The photoelectric work function of the metal is 5 electron volt. Calculate the threshold frequency for the metal. Interesting. If the wavelength is 4000 is incident on this metal, will the photoelectron be ejected? Let's try this out. Interesting question, it seems. Photoelectric work function is 5. Find the threshold frequency. How do you find that? Use this formula. Phi is HF naught. I just gave that formula to you. Work function is the minimum energy of the photon. So energy of photon is HF. So F naught is the threshold frequency that I need. So let's figure this out. F naught will be 5 electron volt divided by the value of H, which is 6.6 into 10 to the power minus 34. But I don't want to leave it like that. I want to find it in hertz maybe. So electron volt into joules. So multiply it with 1.6. Put the value of E, guys, because it is EV. Put the value of E. So 1.6 into 10 to the power minus 19 joules. And here it is 6.6 into 10 to the power minus 34. This is joules second. Joules cancel. 1 by second is frequency, which is hertz. Okay, so 16 5s are 80, so 1 decimal, so it will just become 8, and this will be 6.6 of course, into 10 to the power 34 goes on the top, 34 minus 19, that's 10 to the power 15 I suppose. Now this you can also write it as You can do the calculations on the side maybe. Yep. So this will be like 8 by 6.6 is nothing but 80 by 66, which is also 40 by 33. So if you want to divide 40 and 33, just do the math. You will get to the answer. 133. This will be 7. So point. So 0. So 2. Yep. 66. Correct. And 4. Yeah. So almost like 1.2. So I can just write it as approximately 1.2 into 10 to the power 15 hertz. That's what the answer will be. This will be the frequency. Okay, very, very interesting. So this much is the minimum frequency, which is the threshold frequency after which the photoelectric effect will occur. Ishwara, at least 1.5 hours. Yeah. Sir, can I do these approximations in JEE? Definitely you can do that. No problems. And I don't think we have approximated much. It's like fair enough. It's a decent value only. I mean, I have not done anything crazy. Yeah. All right. Great. Now think about this. The next part of the question says, will light of wavelength this much Armstrong, which is falling on that metallic surface, do you think photoelectron will be ejected or not? Okay. Since I know F naught, let's find the threshold wavelength. Let's find it out. We know that F naught into lambda naught is speed of light. Speed of light is frequency into wavelength. So therefore, lambda naught will be C, which is 3 into 10 to the power 8 divided by the frequency which we just found out, which is 1.2 into 10 to the power 15. Well, I can write this as maybe 30 by 12 into 10 to the power 15 is there, 8 is there, so obviously minus 7. Now this will go 6 times, 6 by, this will become 2, this will go 5 times, 5 by 2 is 2.5, so into 10 to the power minus 7. This is in meters, let's get it in Armstrongs. So this will be 2500 Armstrongs. This is the threshold wavelength. This wavelength is the max wavelength. Remember, this is the max limit for that wavelength. If the wavelength exceeds, energy will decrease, photoelectric effect will not occur. So this is max limit for the photoelectric effect to occur. Now check, is 4000 beyond 2500? Yes. So if 4500 is more than 2500, there will be no photoelectric effect. There will be no photoelectric effect. Okay, for frequency it should be more, for wavelength it should be less. That's the condition. Thank you, Jitendra. Okay, what should its threshold energy be? Yogananda, I just think I have found it out. I mean, I don't even need to find out what is the threshold energy for 4000. I just saw that this wavelength is more than the threshold wavelength. That's it. That's enough for me to say that there will be no photoelectric effect which will be occurring. Yes, 1.207 into 10 to the power 15, and no. We have got the same answers right over here. Got it? Okay. How did you do the calculation journey? Watch the replay again, whichever part you did not understand for calculations. This over here, 5 into 16 is 80, right? So 80. So that decimal became 8. So that 80's 0 went off. And 8 by 6.6. So I wrote it as 80 by 66 divided by 2. So it will be 40 by 33. 33 and 40, you just do the normal division. You will get it as 1.2. And for this, it's simple. 3 by 1.2, I write it as 30 by 12 divided by 6. It gives you 2. Divided by 6, it gives you 5. 5 by 2 is 2.5. That's very simple. Okay. Not that great. Okay. Fair enough. Fair enough. I hope, Tanishq, that is clear how I did it as well. Now, let's talk about the next part. How does changing intensity affect the current of that photoelectric effect? Let's go back to our standard photoelectric effect. Let's make it sodium, our standard metal, and let's see how intensity will change your graph. So let's draw the graph of current versus intensity and see how does it look like. Okay, so we know that if the wavelength is large, frequency is less, no photoelectric effect will occur. If I keep a decent amount of wavelength, then if it is below the threshold wavelength, then obviously photoelectric effect will occur. Okay, now let's see how does the graph look like for intensity versus current. Now observe this, there is no current because the intensity of light is 0. That means no photons only are falling. If no photons fall, why will there be photocurrent? Why do you think there will be photocurrent? Yeah, so there will be no photocurrent. Now I increase the intensity slightly. Now I can see there are some amount of electrons which are getting knocked out. Okay, maybe you cannot see the current over here, but it is very small value. I increase the intensity further. Okay, I increase the intensity further. Okay, am I above the threshold frequency or not? Yes, I am. You can see as the intensity increases, slowly the photocurrent also increases. It increases. You can see that. So more intensity will lead to more current. So that's what you can see right over here. Beautiful. More current, more intensity. Makes sense because more electrons will be ejected because of more number of photons falling onto it. Let's try it out for some different color and see how does the graph basically look like. So if I keep increasing the intensity, you can see the current will keep on increasing, and that's why the graph keeps on increasing over there. You can see that. Now that you have realized that increasing the intensity increases the number of photons, increases the number of electrons, increases the current, and you also realize that the graph will be an increasing one. There is a problem which I cannot show you over here because of the limitations of the software, but I want you to realize one thing. The graph just can't keep on increasing, because if the graph just keeps on increasing, then understand there comes a point where all the electrons are out. Even when the light falls, there is nothing more to be ejected. So when you make the light very intense, there is a problem. Maybe all the electrons are already ejected out. There is nothing more to be ejected out. So there will be a saturation point. I hope this is clear. There will be a saturation point, and before that only you can see the graph is increasing. After that, there will be no more increase in current because you have depleted all the electrons. All the electrons are out. The atom will be like, what will you do? What more do you want? There's nothing more to be ejected out. Yep. So very, very important. So you can see that when the intensity of the light is less, the current is less. When the intensity of the light increases, the current will also increase. But there is always a limit to that. And this graph over here, you can see this is current versus frequency. Notice that this graph starts only after the threshold frequency. Okay, it starts only after the threshold frequency. So below threshold, there is no photoelectric effect. After threshold, you can see the photoelectric effect occurring, and it also depends on the intensity. More the intensity, more is the current. That's what you just saw. Okay, so the number of photoelectrons emitted, that is the photoelectric current, is independent on the frequency. It only depends on the intensity of the light. Very, very important. Very good. So now let's talk about a very does low intensity also eject electrons? Yes, Tanishq, I just showed it to you over here. Even if the intensity is low, as long as your frequency is above the threshold, you will see photocurrent will be there even when the intensity is low. Even if there are 5 photons hitting the electrons, it's okay. 5 electrons will come out. The current will be very, very small, but it will be there. That's how it is. Okay, I hope this is clear. Very good, very good. Now let's go ahead to the next part. Okay, moving on. Yep. Stopping potential. This is the next thing of the photoelectric effect, the next parameter. Only then we can come to Einstein's photoelectric effect equation. See, when light falls on a surface, the photoelectrons get ejected. We have not talked anything about how much voltage you are supplying from outside. What if I change the voltage from outside? Don't you think things will change? Imagine the light is falling, electrons are coming out. What if I change the voltage? Observe this. If there is no external support, there is no help from outside, that is, there is no battery connected, small amount of electrons will be able to reach the other side. There will be some small current which will be flowing in the circuit. Let's say I support it. Let's say I support it by attaching a battery. Then when I support it, the electrons will get pulled and there will be more electrons in circulation. I hope this is clear. So there will be more electrons in circulation because you have supported it with a battery. Look at the terminals. Positive connected here, negative connected here. Negative will repel the electrons, positive will attract the electrons. So more electrons will get pulled and there will be more electrons in circulation. You increase the voltage, you will notice that more electrons will be in the circulation. So current increases as you apply more and more voltage. Very, very important. Helping it, supporting it. What happens if you do the exact reverse? What if you change the polarities of the battery? It will stop the current. It will be against the current. But even when it is against the current, when you reverse the polarity, there will be some small current because there might be some electrons which have a lot of energy to go on to the other side. Observe this. I have reversed the polarities. The light falls on this surface. Electrons are ejected out. If I do not apply any voltage, many electrons will fall here. If I increase the reverse voltage, few electrons will reach here. If I increase the reverse voltage even more, very few electrons will be able to reach there. They will get pulled onto the other side. And if I increase the voltage beyond certain limit, you can see hardly any electrons reach there. So you are stopping the electrons from reaching the other side. So observe this even over here. Now photoelectric effect is occurring. If I increase the voltage, look at this, more positive charge here, more negative charge here. Negative repels, positive attracts, more electrons in circulation. Notice this. Okay, you can see the current increasing as I increase the battery's voltage. You can see that. Okay, I can go only till 2.2 volts, but if I make it little bit less, let's say 0.6, the current decreases. I increase the voltage. Okay, I think we have already reached saturation. Maybe I should increase the intensity of the light. Okay, so look at this. Now I think it will be fine. Look at this. As I increase the voltage, you can see probably, oh, I think we have reached some kind of saturation out here. Maybe let me reduce it. Okay, let's see if it works. Interesting. This should have worked. The current should have increased. For some reason, it is not. Probably a bug in the software. Okay, so it should increase, guys. Okay, it should have increased when I increase the voltage. All right, anyways, let's see if it works in the reverse bias. Okay, if I do it in the reverse bias and if I apply a sufficient amount of voltage, do you see the electrons are not able to even reach there? The electrons are coming out. See, if I increase the reverse bias voltage, the electrons which are coming out are getting pulled back. If I give it no voltage, then these electrons are able to go on to the other side. The positive charge is pulling it. But if I apply negative voltage, then you can see the electrons probably won't reach there. So that minimum voltage for which the current becomes zero is called as the stopping potential. Yep, that's what it is. Very, very interesting. So look at this simulation again. You will probably appreciate it now. Forward voltage increases the current, but you know, the reverse voltage will not be able to increase the current. In fact, it will prevent the current, and the minimum voltage for which the flow of electrons stop is called as the stopping potential. Even the most energetic electron is unable to reach on the other side. So how will the graph look like? That's very simple. Think about it. Current versus stopping potential. This is my voltage. This is my current. This is, let's say, 0. This is your forward bias. Forward bias means you are assisting it. You're helping it. This side is my reverse bias. That means you are against the flow of the current. The battery's voltage is against the flow of the current. So you will see when there is nothing connected, no battery, or even if the battery's voltage is 0, there will be still some amount of current which is flowing. When you increase the voltage, you will notice that the current will also increase. But yes, there will be a saturation which will be reached every time, because there is a limit till which you can pull out the electrons. After a point, all the electrons which are being knocked out are entering onto the other side. They are getting knocked out, they are going to the other plate, and they are into circulation. So there is a saturation which is reached because all the electrons which were knocked out have gone onto the other side. Okay, and on the other side, on the reverse bias, you will see when you increase the reverse bias voltage, you will see the current will drop down and eventually stop. Over here, there is no current after this reverse bias voltage, and this is basically your stopping potential, Vs. Stopping potential has a symbol of Vs. Is this graph understood? Yep. Is this graph understood, my warriors? Very, very important graph. And you should also know what happens if the intensity increases. Remember, I have told you about this. If intensity increases, what happens? More intensity, more photons, more photons, more electrons. More electrons, more current. So you can see as intensity increases, the graph will shift higher and higher, because intensity is directly related to the current. Bias means partial. Are you biased? Maybe a teacher is biased. You would have seen some teachers are biased. Only for some students they will help, for some students they don't help. So bias is when you are partial. So when I say bias, forward bias, that means you are biased or partial towards the flow or the direction of current. Forward bias means you are partial towards the positive direction or the assisting direction. You are helping the electrons. Reverse, that means you are against it. I hope that makes sense. Okay, great. Let's solve some questions based on this. Photoelectrons stopping potential depends on. What do you think does the stopping potential depend on? Frequency and nature, intensity, frequency, nature. Interesting question. What do you think the stopping potential depends on? Very interesting question. Stopping potential. Think about it. Stopping potential. Okay. If you have forgotten the logic, I'll explain again. Let's say there is a photon whose energy is 100 units. Let's say there is a metallic surface and the work function for it is, let's say, 20 units. So how much will be remaining? So the kinetic energy of that electron, how much will it be? It will be nothing but 80 units. Now think about it. In order to stop this electron, you need to suck away this 80 units of energy. And where will that stopping energy come from? It is basically from the stopping potential. So that stopping potential will decelerate the electron and it will suck away all the energy. It will prevent the electron from going to the other side. So what is it dependent on? Think about it. It's obviously dependent on 100. If this 100 was 200, more energy will be there. More potential will be required. So photon means it depends on the frequency, definitely. Photon means frequency. And it also depends on the metallic surface. So if the metallic surface had less work function, maybe 10 units, there would be more energy available. That means it depends on the material. So the availability over here decides how much will be the stopping potential. Hence I believe option A should be correct. So both options, or rather both things are needed, not just frequency, not just nature, both nature and frequency. I hope this logic is very, very clear. Moving on to the next question. A photocell is receiving light from a source. The source is at a distance of 1 meter. If the same source is placed at distance of 2 meters, then the ejected electron will be. Interesting question. So you have a source of light, and you have basically a metallic surface. The light rays which are falling onto it, they are ejecting out electrons. Interesting. Now the distance is, let's say, r. If the same source is placed at a distance of 2 meters, then the ejected electron moves in 1/4 energy, moves with 1/4 energy, half in number, 1/4 in number. Okay, interesting question. So first of all, when you change the distance, what happens? Distance and intensity are related. Remember that? So here, when the distance goes from 1 meter to 2 meter, basically distance has been made 2 times. And I don't know whether you have forgotten or do you remember about this. Intensity of the light is inversely proportional to the square of the distance. Square of the distance. If distance is made 2 times, intensity will become 1/4. Distance becomes 3 times, intensity will become 1/9. So basically the intensity will become 1/4 times. Intensity will become 1/4 times. Everybody agrees to this fact? Next point that I would like to make. How is intensity deciding the momentum or the energy? Well, intensity does not decide momentum. The frequency decides, or the wavelength decides the momentum. So when you change intensity, the momentums won't be affected. Just the number of photons will be affected. So basically number of photons will become 1/4. If number of photons becomes 1/4, then the current will also become 1/4, because the number of electrons ejected out will also become 1/4. So is there an option like that? Yes, option D is correct. Option D should be correct. Will become 1/4 in number. Definitely. Got it? So what was the logic over here? When you change the distance, the intensity reduced. It reduced by 1/4 times. When intensity reduces, less photons will be available, 1/4. So less number of electrons will be ejected out. So if 1/4 photons only are falling, less number, that will be 1/4 only will be ejected out. Moving on to the next question. But before that, the most famous equation given by Einstein. A lot of people think Einstein, got the first Nobel Prize for relativity, but no, in fact, it was for, in 1921 for explaining photoelectric effect. In fact, before that, people used to believe that light is an electromagnetic wave only. Light does not show particle behavior. In fact, much before that, people used to think light was a particle in Newton's era. So for the next 200-300 years after Newton, people thought, light is a particle. But then Maxwell said, no, light is a wave. Then Einstein showed, no, wait a minute, photoelectric effect can be only explained via the quantum theory, via assuming light is made up of tiny packets of energy which are called as photons, which is nothing but particles. Now Maxwell was also correct, even Einstein was correct, and that's why then people decided, okay, so light shows both wave-like characteristics and particle-like characteristics, and that's why they then gave light the dual nature. It exhibits both kinds of behavior. So let's see what is the Einstein's photoelectric equation, which is very, very easy. You will understand it. Very simply put, if light had some amount of energy, out of that energy, some energy got used up in just taking out that electron outside the atom, and the remaining was there in that electron. So can I say that the energy which was there with a photon goes into removing that electron out of that atom? That means the work function, okay, to remove that electron out of that atom, and the remaining part is there as the kinetic energy of that photoelectron. Does that make sense to you? So if this makes sense to you, what is the energy of a photon? It is just HF. What is the work function symbol? It is phi. And what is the kinetic energy? I can just say KE and I can just put max. So this is your very famous Einstein's photoelectric equation. Now some books and some material will also write this equation in different forms. Let's try to write it down. See, you can also rewrite this equation like this. HF is equal to, remember what was the formula for work function? Work function was nothing but H into F naught. F naught was your threshold frequency. That is your threshold frequency. Now, kinetic energy, maximum kinetic energy. How can you determine maximum kinetic energy with stopping potential? It's very simple. Think about it. How is kinetic energy related to stopping potential? Think like this. Whatever kinetic energy the electron has, if you're slowing it down, retarding it, and basically stopping it by applying a potential difference, of Vs, can I not say that kinetic energy will be charge, which is E, into voltage, which is Vs? That kinetic energy will convert into electrical potential energy. That electrical potential energy is always charge into voltage. Charge into voltage gives you energy. So that K is E into Vs. Does that make sense to you? Does that make sense to you? This kinetic energy of that electron gets sucked away into electrical energy. Hence, I can just write this down as E into Vs. So this is another way of writing the same equation. There is no difference between both of them. So this conversion is something which you should know, as simple as that. Yep. I hope this is clear. So what are the different applications that one can think of photoelectric effect? The best one is the solar cells, solar panels, which are used up across the rooftops, or even in your calculators, which are your solar calculators. So it is completely based on photoelectric effect. Light falls on this surface, photoelectrons get ejected, and those electrons get circulated inside the circuit, and they can charge your batteries and they can power up different devices. So that's what photoelectric effect does. Let's see some questions and some beautiful applications of photoelectric effect. Here's the first one. In a dark room of photography, generally red light is used. What is the reason for that? Dhanush, depends on how is your preparation level. Krishna, just leave a comment after the session. Definitely I'll give you the tips. In a dark room of photography, generally red light is used. What do you think? What is the reason for that? Think about it. What's the reason for using red light in a dark room? Like, sir, dark room should be dark. No, why do you have red light over there? So dark room does not mean like a literally dark room. Dark room is that room where, long time back, people used to develop the photographic plates inside the dark room. And in such a room, you do not want the photographic plates to be affected by light. So that's why it is called as a dark room. But you need some light to see something. But that light should not affect the photographic plate. So that light will be needed for human beings, but so that it should not affect the photographic plates. So hence, the correct answer should be, most photographic films are not sensitive to red lights, number one. The frequency of red light is low, hence the energy of the photons is less. Correcto. Atoms Samyukta will be started next time. No, it is not B, Vimal, it is C. Yep, be careful. So this is how a red lit dark room looks like. These are your photographs, which are basically dipped in liquids to basically expose them and to make it into a final copy. So the negatives are seen over here. I don't know whether you have seen these dark rooms in some movies. Anyways, moving on to the next question. The maximum speed of an photoelectron emitted from the surface is V when the light frequency n falls on that surface. If you change the frequency to 3 times, then the speed of the electrons will be how much? Let's try to figure this out. First case, in the first situation, when the frequency of the light is n, the maximum speed is V. So using Einstein's equation, I can say the energy of the photon, which is Hn, will go into nothing but the work function, and the remaining will be the kinetic energy, maximum possible, half mv square. So that's what it is given. The max speed is V, which is half mv square will be the kinetic energy. That's the first situation. In the second situation, when the frequency is made 3n, then the new velocity, let's say I assume it as v1, that equation will look like this. Instead of n, you put 3n. The material is still the same on which the light is falling. So if material is same, work function won't change. So it will still be 5 plus half m v1 square. Great. Now h3n, I can write this as 3 into hn, but hn, I will take it from here. 3 into hn, I'll take this hn, and then I will write the rest of the equation as it is, 5 plus half m v1 square. So if I substitute hn from there, what will I get? Think about it. I'll just get 3 phi plus 3 into half m v1 square is equal to 5 plus half, oops, sorry, that is not v1, that is just v. Just one second, this is just v. Okay, plus half m v1 square. Now take this phi over here, it will become 2 phi. So therefore I'll get half m v1 square will be 2 phi plus 3 times of half m v square. Now what does this equation tell you? Because the question finally demands us to solve it for comparison, for inequality. So I have to compare v1 and v. So what I can do is, think about it, half m v1 square is 2 phi plus this. That means, can I not say half m v1 square is actually more than 3 times of half m v square? Reason? You add something to this, then you get this. So that's why this number should be more than this number, obvious. Now, from this, you can see half m cancels. So v1 square is more than 3 times v square. Therefore, v1 is more than root 3 times of v. So hence the correct answer should be option A, I believe. Yep. Is that understood, bachalo? This is an English channel. I'm Ritesh MTS, so I cannot teach in Tamil. Okay. So, yep. So we have a dedicated English medium channel for all the English medium students. So you need to learn in English, because I hope you have read the name of the channel, bacha, before joining over here. All right. Moving ahead to the next question coming up on your screen. But before that, I want to show you one interesting graph which will probably open up your eyes. See, this graph is so important that many of you probably wouldn't have realized even after seeing it. I'll tell you what this graph is. Observe. Einstein's equation tells me HF is work function plus the kinetic energy which is there, which is maximum. I want to draw a graph of stopping potential versus frequency, which is going to give me a very interesting thing. Observe. See, work function is nothing but HF naught. Work function is nothing but HF naught. Maximum kinetic energy is E into Vs. Reason why I did it? Because there is stopping potential and there is frequency. So I have got stopping potential over here, Vs, and frequency over there on the x-axis. So that's the reason why I have converted into this form. But since I want stopping potential versus frequency, so let's just rearrange this term. It will look something like this. HF minus HF naught is equal to EVS. So therefore, Vs will be divided by E. So H by E into F minus H F naught by E. So I have got Vs as a function of F. This is what I exactly wanted, right? This is what I exactly wanted. So I have got Vs as a function of F. That's what I wanted. Now, observe this graph carefully, because something very interesting is going to happen. If I replace Vs with Y, if I replace frequency with X, and I write it down like this, this looks to me like a straight line equation. Wherever you see Y, all I have done, I have replaced it with, or Vs I have replaced with Y, and frequency I have replaced it with X, because Y versus X. This looks to me like a straight line equation. Now, the reason for writing it down in this form is because I can see H by E is a constant. HF naught by E is also another constant. This clearly tells me one interesting thing. This one over here is nothing but the slope of the graph, because that's what M tells you. M is nothing but the slope, so slope is H by E. Next thing, this C tells you the y-intercept. Y-intercept is nothing but this whole thing. So this is your y-intercept. Now notice that the y-intercept is negative. So that's why the graph starts from here. This is your y-intercept. and the slope is h by e, which is positive, it's a constant. Now what scientists did was basically they have drawn the graph of stopping potential versus frequency for different metals. They found no matter which metal you took and conducted photoelectric effect, always they found the slope of the graph was same. So if you took some other metal, maybe for that metal the graph would start from here, but still the slope was same no matter which metal you took. So they understood, yes, this is something very fundamental and it is h by e, and from the Millikan's experiment they knew charge per mass ratio from charge per mass ratio, and from that they had already found out the value of electron charge. From the Millikan oil drop experiment, scientists had already found out the value of the charge, which was 1.6 into 10 to the power minus 19. From this graph they could find out the slope. They can find out the slope, and from the slope, since you know E, that's how you can find the value of h. So that's how the value of h was calculated. Did you understand this, Anish? Because number one, I've been teaching for a long time. Number two, before coming to the class, I always have a look at all the questions which are going to be conducted. Yeah, usually I look at all the questions. Yeah. Okay, cool, understood, clear, everybody? Yeah, so this is the significance of this graph. That's why it is a straight line, tells you the value of h. Beautiful equation. Moving ahead to some questions coming up on your screen. The stopping potential as a function of the frequency of the radiation is plotted for two surfaces, A and B. The graph shows that the work function of A is, more, less, equal, or nothing can be suggested out of it. Very, very interesting question. Okay, I'll give you a hint. Think about the previous slide, you will get the answer. It's not that difficult at all. If you go to the previous slide, you remember that the y-intercept was minus hf naught by E. So I'll write it over here. The y-intercept was minus hf naught by E. Now if you notice over here, which one has larger y-intercept magnitude wise? Obviously B. A has smaller y-intercept. So the graph that shows the work function of A, okay, is more or less than that. Think about it. If A has lesser y-intercept, it means A has lesser f naught. It has lesser f naught. And remember, what's the relationship between work function and f naught? I have told you this. Hf naught is nothing but the work function. So it clearly means A also has lesser work function. So hence A's work function is smaller than that of B. It's not option A, it is B, my warriors, be careful. A has lesser work function. Hf naught was work function. You can see the graph is ending on a smaller intercept for A, B has larger intercept. So A has smaller y-intercept, so smaller f naught means smaller 5. Yeah, magnitude wise only, yes. Don't worry about the minus sign. Don't worry about the minus sign. Minus sign has already been taken care of because I'm only interested in the length. Whose length is more? B. Whose length is less? A. So if length is less, that means forget the minus sign. This whole ratio is less. That means f naught is less. If f naught is less, phi is less. I have not worried about the minus sign because it will unnecessarily be very confusing then. Okay. So, Rapshil, watch my nurture classes of rotation. Pretty sure you will get it then. The next question is, Lingeshwaram, the playlists are very well arranged, I guess. If there are some issues, please let me know. I'll definitely arrange it. Don't worry. Okay. So you can just tell me which playlists do you think are not arranged properly. But the main Pathfinder and the main Nurture playlists, they have been arranged beautifully. Okay. You can see all the lectures for physics from lecture 1 to lecture whatever I have been conducting. Everything is there. right from top to bottom. Okay, moving on. The correct curve between the stopping potential and the intensity of the light is? What is the correct relationship between stopping potential and intensity? Think, guys. How does intensity affect stopping potential? Well, we all know that if the intensity increases, okay, if the intensity increases, number of photons will increase. If number of photons increases, photoelectrons will increase. If photoelectrons increases, the current which is there in the circuit will increase. But what will not change is when you increase the intensity, the number of photons increases, but energy of the photon is still the same. If the energy of the photon does not change, why will the kinetic energy of electron change? So kinetic energy of the electron will also be the same, and if kinetic energy of the electron is same, the stopping potential will also be the same. So changing intensity changes current, but it does not change the stopping potential. So I think it should be option B, guys. Yes, it is B. So that's it for today's class. We have completed the entire photoelectric effect. We have seen so many kinds of graphs. I've shown you all the simulations. Make sure you go have a look at it. And yes, the entire PDF will be available in the Telegram channel. And these are your homework questions for today. This is homework question 1, homework question 2, homework question 3, and then homework question 4. Make sure you post it up in the comment section below. And remember, you also have the JEE crash course, which has 90 sessions in English medium. You can get the recordings with PDFs, with 10 full syllabus and 10 part tests. You also get to compare your All India rank. You can compare your ranks with the fellow students whom you are going to compete. Actually, not just that, you get chapter assignments and you get summaries, notes, strategy sessions for 20,000 rupees. But with offer, you get it for 10,000. And using my coupon code, usually you used to get 1,000 rupees off. But look at the magic that has happened. I'll just go to the description box. I don't know how many of you have seen it, but it's only live for some days. So if you go to the description box below, just click on the JEE crash course and select your target exam. Let's say JEE 2022. You can select any of the batch that you would like to. Even if you choose 24th Jan, you don't miss any classes because all the classes are recorded. In fact, it is very good so that you already have covered so much of the syllabus. Syllabus will get over fast. Number 2, you can choose which lecture you want to watch in which order also. So up to you, whichever you want to watch. All the subjects are covered, 20 test series, everything is there. When you use the coupon code SHCC, normal discount used to be 10%, limited time offer 15%. That's very, very interesting. So 15% off on this coupon code, you get 8,000 rupees off. That's crazy. That is not your standard offer. Usual offer used to be 1,000 rupees. So you have changed the price and you can see that it has now come down to 8,000. Limited time, just before probably the JEE Mains announcement. So make sure you make the best use of it. You have multiple options to pay, of course. Yes, this crash course is in English, bachalo. JEE Mains registration has not yet started. No, it will take some time. As soon as it starts, I will definitely be here to announce it. Yep. I bless you, Ratneshwar. I really hope that you do well and you become the professor of geography whenever you complete your graduation, post-graduation. Just do whatever is needed. And I hope you develop all the qualities for becoming a great teacher. Thank you so much, Vimal, and have a great time. If you start now Arumugam L, yes, you can crack JEE, but provided you have a decent base of JEE Main, decent base of boards. Also, number 2, even if you can't crack first attempt, by the time you reach 4th or 3rd attempt, you will be in a situation to crack it. A lot of students think that, oh my God, JEE Mains is now, I can't crack it. No. Think JEE Mains is in July, think JEE Mains is in May, then you will feel relaxed. I know you will be giving the first few JEE Mains, but maybe your score might not be that great in the first attempt, but at least in the second and third attempt it will be good. So you have to improve. So take up the crash course, make sure you complete the syllabus in all these classes, solve all the assignments, the Tattva modules, give the tests, improve your marks, compare your scores, use the report cards. You can definitely do it. Thank you so much. Tattva exercise 1 and 2, yep, along with assignments and along with all the sessions that are going on in revision. So if you are in the crash course or if you are already in Vedantu 12th standard or droppers batch, already revision sessions are going on. Even for the crash course students, you will see lectures for test discussion, lectures for assignment strategies. So many sessions are already lined up and students are taking full benefit of it. So attend those revision sessions irrespective of which batch, which course you have enrolled into. So not just Tattva exercise 1 and 2, make sure you attend those classes as well. Okay, great. So if you are in 12th Vedantu JEE batch, yes, there will be sessions already lined up for you, revision classes. So make use of those assignments, make use of those lectures. All right. So Arumugam L, if you are 2023 aspirant, oh bacha, then you have a lot of time bacha. There is a 11th crash course going on. I don't know whether you saw it, it was there right in the description box. So crash course it won't be called as the JEE crash course, but even when you go over here, select class 11th and select your target exam as JEE 2023. 11th standard syllabus revision right now going on with problem solving, application, theory revision, everything. And then you will also get 12th standard complete long term batch, chance to enter into my batch too. And it's for only 60,000 rupees. After using discount coupon code, I mean, it's crazily cheap. It's hardly anything compared to the local coaching fees, and you can try it out for 15 days. When you use my code, you get more 15 days, 1,500 for 1 month. Try it out. Okay, if you don't like it, no problem, don't continue. But at least try it out, complete your 11th standard revision at least. That's what I would say. The pro subscription for class 12th has already started, somebody. So when you enroll into the 11th standard pro subscription, you automatically get pushed towards 12th standard. And I'll tell you the advantage of joining now. You get the entire 11th standard, material also. The 11th standard micro courses, the 11th standard courses, everything will be available to you right now for revision. So don't wait for 12th standard pro subscription batches to start. Start now. That's what I would say. Okay. All the best, Arumungamal. My blessings are always with you. My well wishes are always with you. Okay. Can you only get 12th pro subscription? Yes, but not now. It will start after a few months only. Don't wait for it. Okay. Not now. Only after March. Alright, thank you very much. This was Captain Shreyas and I was going live. Take care. God bless you. Drop the answers in the comment section. Hasta la vista.